Right, so let's start. So last time we discussed about or discussed quick revision on software engineering. We went up to the testing. So now we are moving to our today's session. Oh, we are going to move from that point. So let's start from evolution of maintenance. Okay, evolution of maintenance. So here we didn't discuss the implementation or deployment much, right? So we are just moving to the evolution. Of course, deployment means you deploy the product to the production environment, right? So we didn't discuss that much. So we are moving to the evolution of maintenance. That is, after releasing, still we have to do some stuff, right? So let's discuss what are those stuff and what are the challenges that we are facing and how to tackle in the maintenance or evolution phase, right? So usually if it is a physical product, right, most of the time we just discuss we use the term maintenance. For example, if it is a vehicle, we say we are maintaining the vehicle. If it is a building, we say maintaining the building. But when it comes to software, we combine two words together, evolution and maintenance. So the reason is, once you build a vehicle or once you build a power plant or once you build a say sewing machine, we are not going to change it much. Sometimes no change at all. But when it comes software, once we build the software, we are going to keep on adding some new features and stuff like that. That is the case in most of the case, right? Most of the time we want to do some modifications due to the change in nature of the requirements of the customer, right? So therefore we have evolution and maintenance, not just maintenance. Okay, right? So challenges when it comes to this evolution and maintenance phase, right? It's a long-term task. So that is a very important thing. Maybe you have developed it within 1 year, but you may go into tackle or have this evolution or the maintenance phase for another 10 years or another 15 years. So it's a long-term task and need to work with production and live software, of course, right? So yeah, now you have given the software to the customer, they are using it. You are now at the evolution or the maintenance phase, you are working with the live software. So that means you have a lot of responsibilities. If something goes wrong, it's going to affect the business, right? So it's going to be a real big issue. So therefore you have to be very careful when it comes to work in the evolution phase. Okay, extra care must be taken. Challenges of contractual uncertainties. So that is another thing. Sometimes when we are developing a software, we are just concentrating on the up to the development and release. Sometimes it's very vague or very unclear what kind of obligations you have for the evolution or maintenance. So that is another challenge. So if you have not upfront planned those things with the customer, there will be some uncertainties, conflicts of interest, etc. So you have to plan out those things upfront, and of course if things were not properly done, you have to renegotiate those things properly. Otherwise there will be some conflicting things. Okay, and of course you are working with deteriorating product. So that is another thing. Don't think that when you are keep on maintaining it's going to be better and better. No, it's going to be of course if you are just maintaining it's okay, but the thing is when you do some changes, most of those changes will be unplanned changes. So the things are going to be getting deteriorated when you are keep on applying changes. So that is another challenge. So we have to tackle those deteriorations in the evolution stage. Then the challenges in retaining the long-term team members, right? So there may have been about hundreds of team members involved in software developing that software, but at the maintenance stage we can't keep that much of team members because we are going to have less work. Then when you are losing those key people, the maintenance is again going to be somewhat difficult because those people who really involved in really knows how it works may not be no longer with your team. So you have to work with your existing team members. Okay, so that is another challenge. So that likewise you have to think about practical things. Okay, right? So what are the things that we are going to face? Challenges, right? So what are the tasks that we are going to do at the evolution or maintenance stage, right? Of course we have to do some day-to-day operational maintenance. So because it's evolution and maintenance, we have to support customers. Sometimes the customer himself will do that, his own team, or sometimes separate team has to do that on behalf of the development team. Okay, so that involves user management, because there will be new users joining, new employees joining join into the organization. We want to create them use accounts. Sometimes we want to change their roles. Of course, if it is a connect access is given to the customers, new customers will be needing some user accounts. Then security, right? So we have to monitor and make sure that the things are really secure, backup and restore. So those are the day-to-day maintenance tasks that the team has to look into. Then we have to do some corrective maintenance, right? So if there are any bugs or issues that we want to keep on fixing, right? So that is also part of the maintenance or evolution. Then the customer might come to you, not might, most of the time he will be coming up with some change requests. So we have to attend to those change requests as well. Change request means some modifications or new requirements he is asking. Okay, sometimes you want to do things in a different way, perfective maintenance. Then of course there can be some porting and upgrades, right? So we want to move from Windows 10 to another version, or we want to move from MySQL to the Oracle because of the high load now, right? Or maybe we want to upgrade our web server from PHP this version to another version, right? So that kind of things we want to do. So that is porting and upgrade. So those kind of tasks we have to do at the evolution or maintenance stage. Okay, right. So as I told you, one of the challenge of in evolution or maintenance stage is we are going to have keep on changing software now. So that is called evolving nature of software. So the person called Lehman's came up with some laws. Actually those are not laws like Newton laws or whatever, some observation. He just put it into formal wording. So we call them Lehman's law of continuing change and Lehman's law of increasing complexity. Okay, so what Lehman's law of continuing change says is a program that is used in real world environment necessarily must change or become progressively less useful in that environment. So it's something like that. Either your software has to be keep on change. If you are not doing that, after sometimes no one is going to use your software, right? If you want to make sure that your software is going to be used for long term, make sure you keep doing those changes, right? So that is it, right? So that's it. Something like humans also. As humans, if you are not changing, right? If you are not changing, after sometimes we become useless, right? After sometimes we become useless. Same thing, either you change or you die, right? Change or die, same thing for the software. Either you keep change your software depending on your customer's requirement, or customer is not going to use it. Okay, right. So second law says it's a Lehman's law of increasing complexity. As an evolving program changes, its structure tend to become more complex. Right, so that is all about that. Because when we keep applying some changes, modifications, new requirements, our design, our product is going to be more and more complicated and complicated and complicated. So that is another reality. So we have to face those reality. We have to keep on changing. At the same time, we know that when we keep changing, the product it's going to be more and more complicated. So we have to face those two realities. Okay, right. So when it comes to maintenance or evolution stage, so we are going to discuss some concepts related to that. One of the concept or stuff that we want to do is the configuration management. So configuration management means change management. So as I told you, at the maintenance or evolution stage, we are going to see a lot of change requests coming from the customer, right? Therefore we have to properly manage those changes. So what we have to do is manage the changes. So uh, that the task is called configuration management, right? Right. So how to manage the changes? Of course, we have to plan for the changes and control the changes. So we have to always plan in upfront, anticipating that okay, some changes are going to be there, right? So some change requests are going to be there. And also when a change request comes, we can't just do it, we have to do it in a proper way, and of course we have to do some controlling of that, right? So it doesn't mean that we are going to say no to the changes, we are going to say yes to the changes as long as they are valid, but we are just going to do it in a proper way, right? Not just blindly accepting all the changes. Okay, right. So this is the configuration management or the change management process, right? So when we get a change request, right? So when we get a change request, that can be a new functionality or modification to the functionality. So what we have to do is we have to do an impact analysis. So we have to analyze what kind of impact this particular change has. So it means something like what kind of effort we have to do, right? Is it going to change our design, right? Is it going to drastically affect the existing functionalities? In that case we have to do a lot of testing again. So likewise we have to do an impact analysis, then we have to do a release planning, right? So release planning means, okay, if you have accepted the change, if you are developing this, so are we going to release it in a one release, or are we going to release it in maybe 2 or 3 phases incrementally? When are we going to release those things? So those things we have to plan, because we have to plan those things not conflicting with the customer's business. So that is called release planning, right? So we have to plan the release. Then we can implement the changes, because now we have the release planning. We know that for in this particular day we want to release this feature, in this particular day we want to release this feature. Having that mind, we start implementing to achieve those targets. So that is implementing the changes. Okay, then we have to of course do thorough testing, etc. Then according to our release plan we are going to release it, right? So because now remember we are releasing it to the production, therefore we have to be very careful when it comes to releasing those change requests, right? Because in normal software development cycle your products are going to be released to, right? So 1 minute. Right. So it looks like some students cannot join. I don't know. Right. So if you are joining, you have to join a little bit early, right? So otherwise, I can't attend to issues when once we start the session. Okay, right. Uh, so likewise, first then we have to do the release. Okay, we have to do the release. So again, when it comes to managing changes, so that is from management side, right? Management side, how to work with plan out and those things. Then when it comes to the management of changes, so configuration manage, we have to manage those changing artifacts as well. So changing artifacts means when we are doing some manage changes, of course, the code is going to be changed, right? So the code is going to be changed, the database is going to be changed, right? And then some documents are going to be changed, because whenever there is a change to the design we have to update the design artifacts. Whenever there is a change to the requirements or new requirements come, we have to update the requirement documents. So right, so it's not just you have to develop those things, we have to update the requirement documents, we have to update the designing artifacts, and of course we have to update our code, database, scripts, etc. So we have to do those things in a proper way. So this is not actually only applicable to the maintenance stage, this is applicable to the entire software development, even during the development stage as well. So we have to manage those artifacts properly. For that we have configuration management tools. So we call them what? Configuration management tools. Sometimes we call them the version controlling tools, right? So likewise we can give different names. So there are a lot of configuration management tools. For example, we have the CVS, VSN, another one is a GitHub. So that is again very popular configuration management tools, where in a team environment how are we going to manage our changing artifacts, especially our codes, right? So if it is just one person, you don't have much of an issue, because only you are going to work with those artifacts. But when you have a team about 10-15 team members, there can be a situation where you also want to change that particular file and another team member also want to change that particular file. Now if you take it both take the same file and both do apply the change, and if I have saved it in the common file for the code folder at 4 p.m. and if the other team member saved his version at 5 p.m., all my changes are going to be vanished because he has just overridden my changes, right? So that kind of conflicting situations can be avoided by using those configuration management tools like CVS, SVN, GitHub, etc. Okay, so then we have two approaches actually. Either we have to go for exclusive locking or we can go for the shared locking. Okay, so in exclusive locking, if I want to do some changes to a particular artifact, I will be locking that artifact. So I will be check out this, right? We use the word checkout exclusively. That means we will lock the artifacts and check out it. So that means I have taken the file. I am now doing the changes. No one else can check out it because I have locked it exclusively, right? So then if someone else want to do the changes to that artifact, he has to wait until I checked in. Of course, he can do some changes to other things he has to work on, but he has to wait until I checked in to get his checkout exclusively for him again. So that prevent two people concurrently working on the same artifact, right? So that prevent two people or multiple people concurrently working on the same artifacts and some people losing their changes. Okay, so that approach is okay, but it prevented the other person working on that artifacts parallelly, right? So because it's in a very dynamic environment, lot of team members want to work on the same product at the same time. That is a very normal thing. Okay, that is a very normal thing in real world software development. So this is okay, but it has that drawback of lot of weights, unnecessary weights. So that is why we have another approach that is called shared locking. In shared locking, if I want to work on a particular artifact, of course I can check out it, and also if another person want to do work on the same artifacts, he also can check out the same latest version, right? So now you can see two team members have checked out the same artifacts. Then if I have done with my changes, I can check in, right? I can check in without any issue because no one else has checked in afterwards. So I can check in, but now when the other team member want to check in, now the configuration management tool will say someone else has already checked in, therefore what you have is not the latest thing, therefore you have to what is known as merge your changes to the artifacts because someone else has already done some changes. So what in trivial cases, because I may have added one method, you are going to add another method. In that case, there is no conflict. So the tool itself will merge it. Tool itself is going to merge that change to the configuration management tool. So that is good. That is good, right? So you don't have to worry. We to do those changes parallelly, and now both are happy. But assume that I have changed something to a particular method and you also do the change without knowing that I am changing it to the same location. Okay, within that loop I also change, you also change to do your change. Now it's a conflicting situation. Now the tool cannot merge it without your help. In that case, tool will give error message and say you have to manually merge this. I can't tackle this. In that case, you have to look at the existing the latest code and manually merge it. Sometimes you have to discuss with your other developer and do that merge together, right? Do that merge together. So that is how it works. Of course, that kind of things will happen very rarely, but in that case you have to manually merge it. Most of the time automatic merging will work because most of the time, though it is the same artifacts, you may be working on two different places, right? Two different places of the same artifacts. Okay, so that is actually in real world scenario, most of the time we use the shared locking. If you are working on a real world software development company, of course you are going to use those features right from day one. Okay, so we are learning those things because if you want to be a software engineer, you are going to work with those things, right? So it is not that you are just working alone, right? Okay, So when it comes to software releases, right? So that is again change management. We have to have these concepts called branching and tagging, right? So we are just learning some concept related to in what we do in this maintenance and evolution stage. Okay, so branching means, say I have particular software, now I have sold that software to a particular customer. Now he needs some his customizations. Now I can't do that changes to the main branch or the main branch. Why? Then his specific changes I don't want to be in my main software. So what I do is, in my configuration management tool software, I am going to create a separate branch for my customer called customer A. Right now I have the main software, the general software, and a version of the software for my particular customer. Right. Then if I get another customer, I can do another branching. Now I have the customer A, customer B, and my general software. So that is how we are going to tackle, because some software developers are working on the main software, some developers are working on a customer A's customization, some developers are working on the customer B's customization. Then when you are check out your code, if you are a software developer working on customer B, you have to check out the code related to branch B. If you are working on the customer A, you have to check out the branch A. And if you are working on the core product, you have to check out the main core branch. Okay, so likewise, that is normal case, right? Most of the time there will be that kind of situation. So if you are a software engineer, you have to aware of those things, and you have to know which branch I am going to work with. Okay, then of course we have another concept called tagging. So tagging means, if there is a sort of milestone or release, we just tag that as a release, or major release, or QA release, or whatever, right? So it's like a timestamp, right? In that case, if I want to get some, if I had a real issue with the current bug, it is really unstable or whatever, then we can always get code from a previous tag, so that to see, at least to see what is the issue, or if it is really unstable, we can just roll back these changes up to a particular previous tag. So you can see branching and tagging are two related concepts, right? But two different concepts as well. So they are very useful when it comes to real world software development, right? I am talking about real world software development, how the software engineers work, right? So it is not that conceptually thinking like this is how the software developers are going to work. No, how reality software developers really work. Okay, right. So that is branching and tagging. Then we have a concept called version history also when it comes to configuration management tool. So as I told you, lot of employees are going to, your team members are going to check in and check out your code, same codes, right? So then every time someone check in the code, they have to write a small comment saying what kind of a change you did to this particular file, right? So that version history, if anyone else want to check out, he can always look at that version history, right? So there's a option for view in the version history. There you can see, okay, this particular day this particular user has done this particular change, in the following change is done by this particular user, he has commented saying that I have done this. Likewise, you can see all the history. So that is also very important if you want to backtrack something, or if something is really wrong, if you want to see in which particular version this particular bug was introduced. So that is not to blame that person, just to fix that issue. Okay, so in that kind of a situation, version history is going to be really useful, right? Really useful to feature. Okay, so that every time you check in, that is why we say, as professional person, you have to write a small comment and check in, because that is going to be part of your version. Okay, version history, which is maintained by your configuration management tool. Okay, right. So those are very important things. Then when it comes to releases, so these are different concepts. When you are releasing your software, that is also configuration management. We have to properly manage it, right? So we use some terms, right? So we use a term called version, variant, and release, right? So version, in this case, version means we have a functional distinct specific instance of our software. So that is called a version. So you know that when you are when you are downloading a software also, right? You might be saying, okay, I am downloading Laravel, this particular version, 4.0 version, 4.1 version, or JDK, this particular version, right? To 12 version 12, version 12.1. So that means it's a distinct, functionally distinct particular release, right? So that is called version. Variant means there is no functional functionally it's not differences, but it's something like version 5 Windows variants, version 5 Linux variants, right? Or maybe version 5 Oracle variant, version 5 MySQL variant. So it doesn't have any changes in the functionalities, but there is some distinct in some technical nature, right? Technical nature. Maybe we are targeting for a different operating system, or maybe we are targeting for a different uh, database, etc. Okay, so that is called a variant. So same version might have two or three different variants. Then we have release. Release means again a version, but that version we have released to the customer. In that case it is a release, right, or the users, because there can be some versions which are internal releases, like QA release, right? Just for testing we have given it to the QA team. So there can be versions, internal versions as well, but release means those are given to the customers. So that is why sometimes you don't see in the releases after 2.1, sometimes you don't see 2.2 as a release. All of a sudden you have the 2.3. In that case 2.2 is just a version given to the internal it's sort of internal release, right? So releases are really external things. Okay, so those things are those terminology you have to be aware of, then only you can feel of how these releases are going to work. Okay, right, then we are going to discuss about the concept of forward engineering, reverse engineering and re-engineering, because in the evolution stage we are sometimes what we have to do is the concept called reverse engineering. Okay, so forward engineering means from your requirements we go for the design and implementation. That means the normal engineering process or the forward engineering process. That is a normal case. When you are developing a new thing, we have to understand the requirements, we have to do the designing, and of course you have to do the implementation and testing. So that normal process is called engineering, or we can just say forward engineering, right? Then we can do the reverse process also. That is, by looking at your product, we try to understand what is the design needs, what kind of requirements that they have tried to cater. So if you are trying to do that, right, so very rarely we have to do that, right? But if we are doing that, we call it reverse engineering. Reverse engineering. So that is a reverse process. So why we want to do that is, so there are different scenarios. Sometimes say you are a new architect, right, for that software, particular company. Now assume that you have the company is having a software or system which they don't have any design documents or requirement documents or whatever. They just have the software and the source code. In that case, if they ask you to do a modification, you can't just start doing the modification. Of course, assume that you have the source code available. Then you have to, because they have not provided you the design artifacts or the specification artifacts, now you have to do this reverse engineering, right? Then only you can understand what is their design, what kind of requirements they have catered. Then only you can do your changes, right? So initially you have to do something called reverse engineering. So that is why we say when you are acquiring a software, make sure that you get all those other documents as well. Otherwise we have to do this reverse engineering as development team. Okay, so that is called reverse engineering, right? And also you know that lot of times when Apple release a phone, in 3 4 months all of a sudden China release a duplicate. So how do they do that? They heavily do the reverse engineering. So they analyze the existing product and they come up with a duplicate product. Of course that is an illegal thing, but what they are really doing is reverse engineering. Okay, so Chinese people are not good at forward engineering. So the American people and other European countries are really good at forward engineering, whereas Chinese people are really good at reverse engineering. Okay, right. So, so that is reverse engineering. Then what is re-engineering? So re-engineering means you do the first you do the reverse engineering, right, to understand the current requirements, current design, etc. Then you want to improve it. You want to improve it. You have apply lot of improvements, new features, etc. Then you apply those things, ideas, you again develop it or do some modifications to come up with a better product, right? Complete, sometimes completely different, innovative product. So that whole process is called re-engineering. So re-engineering involve initial reverse engineering, apply some changes, improvements, then the improved product you are going to again develop. So that is called re-engineering. So the where are we going to use re-engineering? Of course, heavily we use re-engineering, right? Why? Rather than developing a completely new product, if you can re-engineer it again properly, it's going to save a lot of money, and also it is going to be less risky as well, because you already have the product, right? So that is what we prefer. As much as possible, we try to do a lot of re-engineering. But there can be a situation, now it is no longer re-engineering is possible because our software is really deteriorated, it's really not up to the current technologies, etc. In that case, we are going to stop this re-engineering process and start with a fresh development. Okay, start with this fresh development. Okay, so that is how it works. So but as much as possible, we try to do reverse engineering in a proper way, because it's going to be less costly and less risky. Okay, so rather than just developing a whole new thing. Okay, okay, so that is reverse engineering. And right, so now we are done with evolution and maintenance, right? So we discussed some concepts related to uh, evolution and maintenance, especially the concept of configuration management and the concept of reverse engineering. Okay, right. So now we are done with the life cycle. Okay, now remember we start with analysis, design, development. Of course, we didn't discuss the deployment or implementation. But anyway, you must have that basic understanding that you learn in your other semesters. Then we discuss the evolution and maintenance. Now we are done with the stages. Okay, now we are going to discuss some few concepts related to software engineering. Right, few concepts. So likewise, always you must have that big idea. Right, big idea. Now we are done with the life cycle. And now we are going to discuss some isolated topics related to software engineering, like use of case tools, right? Importance of project management, stuff like that. Okay, right. So let's start with use of case tools, right? So case tools stand for computer aided software engineering tools, or case tools, right? So case tools means or use of case tools means use of software for software engineering process, right? So of course we are developing a software, to when we are developing the software also we can use some software for our help. So that those softwares are called computer aided software engineering tools, so case tools. Okay, so it's very simple. Right. So why we want to use case tools, or why we want to use some software in when it comes to developing software? Of course, there are hundreds of advantages. So we are just listing the very important one only. So of course, when you are using a tool or software, it's going to improve your productivity, right? So rather than writing your code using Notepad, if you move for integrated development environment like IntelliJ, right? It's definitely going to improve your productivity, right? So you are going to write more code in a day than just using the primitive code, because it gives you a lot of hints, it gives you a lot of code formatting features, errors will be shown then and there, right? Refactoring, right? So integrate to compile and running. So that means your productivity is really high, or your team's productivity is really high. So that is use of case tool. Then better quality. So when you are using a when you are using a tool, is going to improve your quality also, right? So rather than you are using a notepad, if you are using your IDE, always your IDE is going to help you indent your code, format your code, because it's just control A, control F, right? Select all, format. So you are always going to keep your code nicely formatted, right? So likewise, things are going to be really consistent because everyone is using the same tool, right? So it's going to improve your quality of the product, right? Then of course, as I told you, it's going to improve the consistency. Of course, that is if everyone is using the same tool, right? Or the compatible tools, it's going to be really consistent, right? When you are using tools, right? And you can automate trivial and repetitive tasks, right? So there are boring tasks and there are interesting tasks, right? So boring task means something which is very trivial, right? Something which is not challenging, right? So people don't like, engineers don't like to do trivial tasks. They like to do interesting tasks. They like to challenging tasks. So trivial tasks can be automated using tools, right? So things like building, right? Releasing. So those things we can do by using the tools. So we can just concentrate on designing a new thing, right? Come up with a solution. So those kind of interesting tasks that software engineers concentrate when the trivial tasks are taken care of by the tools. Okay. Then of course tools are going to facilitate teamwork as well, right? Like the configuration management tools, as we already discussed, right? And also communication tools, right? So of course when it comes to real world software development, they are always in this chat. They are always in the chat because they want to get help from others, right? So they can just chat with your fellow programmer because they don't want to always disturb others, because remember in software development environment, we are concentrating on a solution, right? Of course we want to do a joke, laugh at a time, but that must not be the case all the time. Therefore sometimes developer next to me or facing me, we prefer to sometimes just chat him and say, please come over here, I have a small issue that I want to discuss. So communication tools are really important, right? Communication tools are really important. Then he will quietly come to you and take care of your issue, right? So likewise, there are so many places we can use tools, right? We can use tools, right? So let's see for what kind of a task we can use the tools. Of course, the one of the very famous one is the modeling tools, right? If you want to draw a class diagram, use case diagram, ER diagram, we rather than using the pen and paper, we can go for modeling tools, right? So it doesn't mean that every time you have to go for modeling tools, but if it is a really big software, sometimes we want to use a tool, right? Because there are a lot of advantages. If you want to do some restructuring, if you have used a pen and pencil, you have to do a lot of erasing and stuff like that. But if you have to use a tool, you can straight away drag and drop and do it. Other thing is you can easily email it to someone, right? Otherwise you have to scan it, right? So likewise there are a lot of advantages when it comes to use of tools, right? Then there are development tools, of course, something like IntelliJ, right? Dreamweaver. So it will help you coding, right? Coding, testing, etc. Unit testing. Then there are some test automation tools, right? If you want to run your unit test cases, if you want to do some load testing, you can use those tools as well. Of course load testing is always done by using tools like load runner. Then we have the build tools, right? If it is a really big software, we have something like Ant, Maven, right? So those kind of tools, right? If you are using the PHP, you have a tool called Composer, so that most of your final year students are already using that tool. If they are using the PHP, especially they are going for the frameworks like Laravel, they always use that build tool called Composer, right? So those things that you learn here, you are going to use those things, right? Those who have not learned those things, they are not going to do their final year project, or they are not going to do any real world software development, right? So that is for sure, right? So therefore you must have that feeling, right? Not just study or memorizing like blind people. Okay, so you must have that real world feeling of how things are going to be done. Okay, then of course configuration management tools, as I told you, CVS, VSN, right? GitHub configuration management tools. Project management tools are there like MS Project, and there are a lot of online project management tools to draw Gantt charts, PERT charts, etc. Then there are prototyping tools, right? A lot of wireframe tools are there. Reverse engineering tools are also there, where by looking at your code or the database, they can just come up with the ER diagram. Actually, a lot of students use that when it comes to final year project also. So we have for the MySQL, we have a tool called MySQL Workbench. Sometimes they just create the database without doing the ER diagram properly. So then what we say is use the reverse engineering tools in your MySQL Workbench and come up with the ER diagram. So it will just draw the ER diagram within seconds, right? So you don't have to draw it. So that is good. So that is reverse engineering. You have already created your database. Now you want to see what is the design is. Actually, that is not the preferred way. Preferred way is you first you do your design and go to the database. But sometimes in a hurry, people do in other ways also, right? That is a reality, right? So in that case also there are tools, right? So that is good. Reverse engineering tool. It's the menu option specifically say reverse engineer the database to the design. Okay, right? So you must aware of these things. Otherwise, you don't know what is this tool is going to do, right? Otherwise, you are not aware of that there is a tool like that. So there you are going to spend some time manually drawing the ER diagram, right? So you have to aware that these tools are there. Okay, then we can again classify these case tools into three categories, what is known as tools, workbench and environment, right? So it's something like a workshop environment. So tool means individual thing that we use to one specific task, right? Maybe notepad plus plus. So we use notepad plus plus only for development coding. So that is a tool, okay? Or maybe something like ant or composer. So it is used only to do some building, right? So that is a tool. It does one specific task. Or maybe ant or Java. For the Java we have a build tool called ant, right? And another thing is load runner. Load runner is there to just do your load testing, nothing else, right? So that is tool, right? So we just call it load runner tool, right? Then we have workbenches, right? Workbenches. So workbench is capable of doing not just one task, it can do maybe 3 or 4 tasks together. So that in that case we don't call it a tool, we call it a workbench, right? We call it a workbench because it is capable of doing multiple tasks, right? Very good example is lot of final year students are using MySQL workbench, right? MySQL workbench. So you can see the name itself is MySQL workbench. You can pre-download it from the Oracle site. So there, as I told you, you can query some SQL. You can query your SQL database. So that is development related things. Then you can draw your ER diagram. You can do some reverse engineering. So those you can see multiple tasks you can do. So therefore, we don't call it MySQL workbench tool. We call it we don't call it MySQL tool. We call it MySQL workbench, right? So that is a workbench. So likewise, there are that kind of softwares you can do multiple things, right? You can do multiple things. Even if you take something like IntelliJ, it's sort of a workbench, not just a tool, because you can code it, you can build your code, you can run your unit test cases using that tool. So it's also pretty much a workbench, though we don't call it workbench. Okay. Then we have the environments. Environments means it's pretty much covering entire software development process, right? There is no workbench that is covering entire thing, but it is more than workbench. It is more than workbench. Then we call it environment, right? So very good example is something like the Visual Studio. Visual Studio is pretty much like an environment because it supports lot of things like creating some models, coding, testing, building, and also sometimes it has some configuration manage capabilities and also some project management aspects as well, right? So very little project management support is there, but there are some plugins, right? So therefore it's like an environment, right? Environment. So if it is going to support from end to end sort of a functionalities, we call it an environment. So now we have the tools, workbench and the environment. So you have to know whether you are working with the environment, am I working with the workbench, or am I working with set of tools. Okay, right? So that is how we categorize the case tools. Okay, so have those in your feeling. Okay, so don't just dryly look at those things. Right, now we are moving to another topic. Remember, I told you when we were doing the testing is just part of quality assurance, right? So the big thing is the quality assurance, right? So of course, in the new syllabus, you don't have in final year software quality assurance as a subject, but in new syllabus, we have another subject called software quality assurance. Now you can see why they have added it, because of the importance of it, right? So remember, this quality assurance is a very important aspect in software development. Remember, in the very first slide we discussed what are the challenges we are currently having in the software field. One of the challenge I mentioned is still software is having a lot of bugs, right? So still softwares are having a lot of bugs. We want to get rid of that. We want to make sure that our softwares are all high quality products. So one of the way we can achieve that is have a lot of focus on software quality assurance. Okay, so a lot of software developers, they don't have that mindset, right? They don't have mindset. Of course, when you learn these concepts as your subject, of course, we hope that those things are going to be part and parcel of your thinking, right? So you are quality conscious person. So okay, so that is why whenever someone says මේ එක්සෑම් එක ගොඩ දාගන්නේ කොහොමද? හරි මේක යන්තම් පාස් වෙන්නේ කොහොමද කිව්වම අපිට hina යනවා. මේගොල්ලෝ නම් මහා ඉන් software field එකට හරියන කට්ටිය නෙමෙයි කියන්නේ. මොකද ඒගොල්ලෝ field එකට ගිහිල්ලත් කරන්නේ මොකද්ද? software එක යන්තම් ගොඩ දාන විදිය තමයි හොයන්නේ. හරි ඒගොල්ලෝ ගන්නෙ නෑ ඇත්තටම. ඒගොල්ලන්ට පුළුවන් වෙනම job එකක් කරන්න. හරි. ඒක software field එකට අපි ගන්න හොඳ results තියෙන කට්ටියව තමයි ගන්නෙ. මොකද අපි දන්නවා නැත්නම් මේගොල්ලෝ ඇවිල්ලා software එකත් යන්තම් ගොඩ දාන්න try කරනවා. ඒගොල්ලෝ අහනවා ලැජ්ජ නැතුව ගිහිල්ලා මේ ගොඩ දාගන්නේ කොහොමද කියලා නේද අහන්නේ forums වල. ඉතින් ඒගොල්ලොම වැඩක් නැහැ. So what we need is people who are really quality people, right? Quality people, so who can develop a software with real high quality, right? High quality software. Okay. දැන් කියන්න එපා අපි exam එක කොට දැම්මට එතන ගිහිල්ලා හරියට කරනවා කියලා. එහෙම වෙන්නේ නැහැ. It's your attitude. It's your attitude, right? So we know your attitude is attitude, right? Okay. So what is mean by quality? So quality means fitness for the purpose, right? If something really fit for my purpose, that is quality, right? That is quality, right? So it is not that I need a perfect product or I need a product with all the features in the world. No. If something fit for my purpose, that is quality, right? That is quality. For example, if when I buying a mobile phone, I have set of requirements, right? If it does the purpose, I don't mind whether it is a 2 lakh or whatever or 30,000. I will buy that product with the lowest price, which has that quality, right? If I can take calls, if I can browse the internet, right? So if I can have install some apps, that is my requirements. If it is fit for my requirements, and of course, if I know that it is with reliability. For example, my requirements may not be that I am taking lot of pictures. Then I don't mind the pixel depth of the thing because that is not my requirement. So you can see it's all about fitness for the purpose of your customer. As long as it's fit for the purpose of the customer, that is a quality product. Of course, if it is not fitting, that means if it has some issues or whatever, or if it does not have some features, that is not a quality product. Okay. Then of course, we want to make sure that there are no bugs that prevent use of it. It doesn't mean that it is zero bug. Right? So there are no bugs that prevent the use of it, effective use of it, right? So then it's a quality product, right? So therefore, we don't blindly try to make it perfect thing, right? Because whenever we focus on quality, there is a cost factor. If cost is too much, the product price is going to be too high, right? Product price is going to be too high. Therefore, we want to balance it. We want to have a reasonable cost product with reasonable high quality. Okay, right? So that sometimes happen, right? So that sometimes happen. Sometimes some people are really too much quality conscious also, right? Some people don't care quality also, right? So don't care quality people, they come up with a very poor product. Too much concentrate on quality people, they spend too much of time and money on that product. Okay, right? So what are challenges when it comes to quality? There are some challenges. Yes, there are some ambiguities, because when I say quality, different people look at it in different ways, right? So quality for one person is not the quality for another person, right? So same thing, right? One person might buy a Apple phone, another person will buy a some sort of a Samsung phone, right? So maybe he will say this is the quality I am expecting. Another person will say this is the quality I am expecting. So that is ambiguities. Right? Because they look at things in different ways. So that challenge is there. Right? Then the conflict of interest, right? So different people will look at quality in different ways according to their interest, right? So developers will look at it in one way, right? Project manager might look at it in different way, and your customer might look at it in different way, right? So that conflict of interest is also there, right? Then the cost aspects, as I told you, we have to balance the quality and cost together, right? If you crazily go after quality, right, sometimes the cost is going to be way high. So we want to balance it. We want to have a reasonable quality product at reasonable quality, reasonable cost. Okay, so we have to balance those things. Otherwise, the cost is going to be too high. That means you lose your competitive advantage. Okay, At the same time, if the quality is very low, again you are in trouble. No one is going to use it. Okay, right. Right. So what are the key factors when it comes to quality? Or if you want to have proper quality product, so we have to think about these things. The first one is organizational commitment. So as an organization, right? So your organization management has to commit to quality. So there are that kind of situation, right? So some people are not committed to quality, right? Some people are not committed to quality. If your organization is highly quality conscious, then the workers are also going to follow that. So that is organizational commitment is needed, right? Need for standards. So we must have some standards specified at our organizational level, at our team level, and of course at individual levels. We are not going to violate those standards, right? So then only it's going to be happen, right? For example, now some of the students have standards. So their standard is I am not going to fail any subject. So that is my standard. So failing a subject is a real bad thing for my image, right? I really upset. So that is their standard. Some students have standards. Okay, I don't care whether I pass or fail. I just want to go through this. Maybe in next century I'm going to get my BIT degree. That is their standard. But when it comes to quality, we want to set high standards. Then only everyone is going to achieve that high standard. Okay, so that is need for standard, right? Then independency for the quality assurance. So that is why in every project we have this kind of hierarchy. So that is very important. If so some of you may have already working in software industry, they know this, right? So you have the project manager. So this is for big projects, like if you have about 20-30 members. Under project manager, we have, so this is a conventional setting, right? Most of the time it is not the project manager. Now we have the scrum masters, but let's take the conventional scenario. We have the architect or tech lead, and here we have the QA lead or QA analyst. Right? So here we have the architect or tech lead. Under him we have the software engineers. Here we have the QA engineers. So we have just separated. We have separated. These guys are involved in development. Of course, they have to do their unit testing or the system testing thoroughly. But these guys are not involving in development. They just concentrate on testing. So that is independency for QA. Independency for QA. So these QA engineers are going to work with the QA engineer, sorry, quality QA lead, right? So they are independently verifying your product. If these people are, if your QA engineer is also doing some development, if your developer is also doing some QA engineering, it's not going to work, right? It's not going to work. So when these guys are looking at it in a fresh way, then a lot of issues are going to be surfaced and identified. So therefore we have a separate hierarchy here, independence of for QA. So if you go for software development company, you will all of a sudden see that okay, we have tech lead in this project, we have quality assurance lead in this project, right? Under QA lead we have quality assurance engineers, under tech lead or the architect we have software engineers. Okay, so we have that independence for the QA. Then only they are going to be very effective identifying issues, right? So remember, these QA people are not to identify your issues. They are to identify the issues in the product, because we want to have a very good high quality product. Okay, so therefore these people have to collaborate with each other. They are so these guys are just to help these software engineers, right? So if they are not having a fight or whatever, right? Right, then the total quality management. So the total quality management says we have to think of the quality as a total thing, not just I individually we are interested about having a high quality product. No, it's not going to work, right? So we must, if we want to have high quality product, the concept of quality must be throughout the organization. Throughout the organization, everything must be quality. When everything is quality, obviously your product is also going to be quality. So that is why when it comes to software development companies, right, so they think about this total quality management. They always, when they are hiring new people, they make sure that only high quality people are taken into their projects, right? So because it's total quality management, and also they make sure that you are given high quality environment, right? So high quality environment where you can do your work, right? So nice quiet environment where you can do your development, and sometimes they even provide you high quality foods, etc. also, right? And also provide you transportation and stuff like that. Why? they want to make sure that everything is in high quality. And also then when the things are really high quality and you are working in an environment where everything is high quality, all of a sudden you are going to, if you, of course if you have that attitude, so that kind of people only they are taking into the project also, then invariably your product is going to be of high quality, because it's a part of the quality culture, right? Part of the culture, right? So that is why when something is developed by Japanese people, it's high quality. Why? Japanese people have that quality culture. When something is developed by a European country, it's of high quality, right? Why? The culture is high quality, right? If you take something like something developed by Sri Lankan culture, it is not of low quality. Why? We don't have a quality culture, we have a low quality culture. අපි තේ එකක් හැදුවත් එහෙම ගණන් ගන්න නැහැ. හරි? පොද්දක් හැදුවත් ගණන් ගන්න නැහැ. වැටක් ගහුවත් ගණන් ගන්න නැහැ. තාප්පයක් බැන්දත් ගණන් ගන්න නැහැ. පාරට ගිහිල්ලා බලන්නකො කඩයක බටු ටිකක්වත් හරියට මේ කරනවාද කියලා නේද? So that is පාරට බැස්සකම අපිට වෙනවා මේ quality නැහැ. හරි? බස් එක නැගගම පේනවා අපිට quality නැහැ. මේ මිනිස්සු නිකන් සත්තු වගේ හැසිරෙන්නේ. ඉතින් සත්තු වගේ හැසිරෙන බස් එක නැගලා යන මනුස්සයා ගිහිල්ලා වැඩ කරද්දි අර quality එක නෙමෙයි වැඩ කරන්නේ. හරි? ඒක තමයි අපි කියන්නේ සමාජයක් විදිහට quality culture එකට යන්න ඕන කියලා. හරි? ඒ වගේ තමයි. ඔයගොල්ලෝ එක්සෑම් එකක් කරන්නේත් එහෙම quality නැහැ. ඔහේ අනාන කරනවා. So ඉතින් ඔයගොල්ලෝ එතනට ගියාට පස්සෙත් ඒක quality නැහැ. So that is why we want to make sure that when you are studying, right, in your society, so we want to make sure that everything is in, of course we can't influence the society, at least in the working environment, organization level, we want to have that quality culture, right? Quality culture, then of course they are going to come up with high quality products. Okay, so that is called total quality management. Right. So when it comes to quality assurance, we can identify three key activities, that is quality assurance, quality planning, and quality control. Right. So quality assurance means we have that policies, procedures, standards, etc. set up. So that is called quality assurance. Right. So remember this word assurance, and now remember there's a term called assurance and there's a term called insurance. Right. Insurance, assurance. So what is the difference? For example, we have union assurance, but we have something like Sri Lanka insurance. So what is the difference? Assurance means we make sure that nothing goes wrong. We make sure that nothing goes wrong. So that is called assurance, right? Right. So quality control means we control that things are controlled and check whether things are really in good shape. Right? So that is the difference between assurance and controlling. So for example, code review is part of the quality assurance. Right? Code review is part of the quality assurance. Before identifying bugs, we want to make sure that there are no bugs in our system. Okay, right. So then we have to do quality planning. Plan out when are we going to do the test case writing. How many quality assurance engineers we are going to have it. When are we going to do the testing? So we have to have a plan, right? Then the quality control, that is executing the test cases, identifying bugs, asking the developers to fix it, again retesting. So that is quality controlling. Okay, right. Right. So when it comes to standards, so remember I told you that every organization must have high standards. Then only everyone is trying to be in that standard, right? So and also as a customer, we like to get something done from high organizations having high standards, right? Organization having high standards. So that is very important, right? So when it comes to standards, we have two types of standards, what is known as product standards and process standards, right? Product standards and process standards. So product standards means standards for a product, right? Process standard means we standardize what the quality of the process, right? So when it comes to manufacturing industry like soap or maybe electrical goods, etc., they have product standards, right? Product standards. But when it comes to software field or the service field, right, we have the process standards, right? So in the service field, we can't have a product standard, because we can't have a product standard for health, banking, etc. Why? What we can do is standardize and evaluate what is the standard of their process, right? And this is the same for the software also. Though software is a product, it's a one-time product. We are not going to release the same product again and again, like sunlight or whatever. So every day they are manufacturing sunlight, same sunlight. So they can have the product standard, but we are not going to manufacture any software again and again. If you are working on one particular software these days, in next day we are working on a different project. So therefore, no point having product standard. What we need is a process standard. Are we following the proper process? Right? Are we following the proper process? That is what is they check. Right? For example, when it comes to institute also, so BIT institute also, for example, UCSC, sometimes they check whether are we following a proper process. Right? Are we following a proper process? Because of course they can look at our results and evaluate us. Right? It's something like a product standard, but each year different students are there. Right? Each year different students are there, but process standard means they check whether are we following the proper process. So that is also important. Right? Right. So there are two major process standards when it comes to software development field. That is the CMI standards and ISO standards. Right. CMI standards mean for capability and maturity industrial standards. CMI, or it's given by the Computer Engineering Society. That is the most widely used standard in software field. Then we have the ISO standard as well. So actually, software field do not much use ISO standard, but that is the most widely used standard in the world. Okay. So let's discuss about only CMI here, because in your note we have given some more information what ISO standards are related to software field, etc. Because this is a big division, I am not going to touch it. Now remember, I am not going to cover everything. You know that everything I can't cover within 4 hours, right? So for 3 hours, just I am giving you the mindset, right? So giving you the mindset, what kind of things you want to concentrate, the big picture. Okay. So when it comes CMI, so that is the most important or widely used standards. Uh, it has several levels also. So what is known as level 1 to level 5. So if your organization is in level 5, that is really good. Actually, the CMM standard is given by the that computer engineering society. It's an independent body, so they do independent auditing. So of course, if your software development organization need that standard, we have to apply it formally. Then they come to the organization, not just they just sometimes they stay with the organization about 2 3 days, observing, interviewing different people to see whether they are really following the standard. Of course, they are going to check whether some of those artifacts are there, whether you have a proper configuration management, or is it properly used. They will check your code and see whether are you following the coding standards, and they will ask you where is your coding standard document, and they will check the coding standard document and random code and see whether the engineers are following the standards. So likewise, and are you having the meeting minutes, right? So stuff like that they are going to check or audit. If they are really happy, of course you are going to get the 5, but most of the software companies are somewhere in level 3 or 4. Very few companies have reached level 5. Okay. So level 1 means you have the initial set things done, right? Level 2 means now it is repeatable. That means you have some process now, right? So the level 3 means you have sort of a consistent process, or you have very good standards now. So that is, now we are in the level 3. Level 4 means your process is really predictable. So that means it's really matured process you are having, right? It's very predictable process. So then they are given the level 4. Most of the software companies are in level 3 and 4. Level 5 means you have an exceptional process, something like you are doing things in a exceptional way that your other companies are not doing, right? So you have this lot of best practices, you have excel in your field, right? You are following some processes which other companies have not even thought of it, right? So that in that kind of a mindset, we say that you are in a level 5 or CMM level 5, right? So when it comes to customers, they like to get their software development done by companies having high CMM standards. Okay. So that is important. So it's something like you have A plus, A, B, C, something like that. So everyone is like to get higher people having A plus or A, right? So it doesn't mean that having A plus is going to be the only scenario. If you have A or A plus, and in the interview, if you they found that you have a really good attitude, you are a really skilled person, yes, right? So that is how it works, right? So A plus or A is not going to automatically make you a good person, but if you have A or A plus or B or whatever, it shows that you do things in an excellent way. Your quality is really high. Your quality is really high. Okay, right? So same thing, right? So that is why they are given these CMM levels by Software Engineering Association. Then customers can easily figure it out which organization we want to go, right? Right, so that is CMM levels. Now we are finally going to discuss a little bit of software project management as well. Anyway, we discussed about the importance of managing the project in the very upfront, right? Remember we discussed how we are going to tackle it: software engineering, agile development, project management. So there we discuss. Actually, these slides are repeating now. We discussed these slides in the very first set of slides as well. Right, so remember, project management means managing the project, right? Managing the project. So that is how we have the, anyway you have the project management as a subject in your next semester 4, managing the project. Okay, so first you have to understand what is mean by management. So management means doing things in a systematic way, not just doing for the sake of doing, right? Doing things in a systematic way, right? So ways that people have identified as the proper ways. Okay, so that is called management. So how do manage things? Oh, I don't like to word how do managers work, because everyone has to be a manager of its own task. So how we manage things? We plan, organize, lead, control. Of course, there are some auxiliary tasks also which we will be discussing under management. So you have the management in your final year. So there are some auxiliary things like communication, right? So the stuff like that is there. But major four tasks are plan, organize, lead, and control. So you don't just do something, you plan out things. You don't just do things, you organize the resources, etc. Right? Then you take initiatives and do things. Right? So you don't wait things to happen. Right? You don't wait things to happen. For example, now I saw that in the WhatsApp groups, person has asked me when are we going to do the maths. So that is good, right? So we don't take it as a bad sense, right? So that means that person has initiative, right? So about 2 weeks back I saw some person has asked me why are we not having class this weekend. So that is good. So that means they initiate things, right? Sometimes if when things are not going the way you like, you want to control it, right? So sometimes maybe I am lazy, right? I am lazy, I am concentrating on something else. You want to get the attention back because you want to get this finished, right? So you don't want to do this forever. Actually, that is what I am thinking of. Finish this all these sessions in about 2 weeks time, right? Maybe I think අපි මේ අනාගෙන අනාන ඉන්න ඕනේ නැහැ නේද? So I am planning to actually is to finish all the mathematics in I'm actually if things goes correct, right, I'm going to do mathematics session in Saturday as well as Sunday and maybe Monday also, and finish the maths. Okay, so likewise now I'm going to finish software engineering. Likewise, we want to finish things. So that is another thing that you learn in project management. You start something, you do it, you finish it. That is how we do things, right? Project managers do things. You start, do, finish, right? A lot of people don't know how to finish something. They start and they are doing it forever. They are doing it forever, right? They are doing the same thing, right? So managers, they don't do that. So the people who know management, they plan, organize, lead, control. They start, do, and finish, right? Start, do, and finish. No, it is not that every day, every time they are saying I'm doing. No, that is not the case. Professional people, they start, do, and finish. So that is why we want the university to very quickly schedule your exams. Okay, so actually I'm really upset now. I thought that they are going to schedule it by now. Now things are really coming to the normalcy, right? So they must very quickly schedule their exams, maybe in the latter part of the July, and finish it, right? So then you can concentrate on your next semester and your other tasks, right? Otherwise it's wasting of your time, right? Of course this is not wasting of your time, this is due to the current reality, but again we don't want to drag it, right? So right, so we want to do it fast, right? ඔයගොල්ලෝ මේ දවස් ඡන්දයක් ගැන කතා කරනවා නේද? එක කට්ටියක් කියන ඡන්දේ කල් දාමු කියලා, තව කට්ටියක් කියන නෑ මේක කරලා ඉවර කරමු. So I like that attitude actually, right? හරි, ඔය ඡන්දේ කල් දාමු කියපු හාල් පාරුව තමයි අර යුද්ධේ අනා හිටියේ. හරි, ඒ මිනිස්සුන්ට යුද්ධ කරගන්න බැරි වුණා අවුරුදු 20ක් තිස්සේ. හරි, අනිත් පැත්තට එහෙම නෑ. ඒගොල්ලෝ so they have a lot of issues also, but I like that attitude, right? So they don't care, they don't fear of things, they want to face it and see the success. So that is very good, and that is really really good. So other people, they like to keep postponing things, right? So that is really really terrible kalakanni attitude. Okay, right? So so you plan, organize, lead and control. Okay, so that is how manage things, right? Then you must have a very good understanding about the project. So you must have a set of team, and one of the person will be the leader, right? We call it project manager or team leader, or in agile development we call him the scrum master. And we want to achieve that objective, we want to achieve objective or set of objectives. So what are the objectives? Delivering a quality product within the time frame with the given cost, right? And that product must have the original scope we have specified. So that is our objectives. So that task is called the project. So that task is called the project. Okay, so project has project members and the leader, right? Leader. So when it comes to project management, we have to think about those four aspects, the key aspects. There are some other aspects we will be learning in project management subject, but the key aspects are managing time, managing cost, managing scope, managing quality. And so that means we want to have our product with given at a specified time, within the specified budget, with the specified scope, at reasonable or high quality, right? So that is all about managers try to achieve all those four objectives: time aspect, cost aspect, scope aspect, as well as quality aspects. Okay, so that is what it's all about. So that is not easy, right? So you have to tackle multiple things together, right? Sometimes it is conflicting also, right? So for example, when you say high quality, engineer might say, okay, I need more time, right? But the project manager say, no, I can't give you more time, but still you have to achieve these qualities, right? So that is why you have to be a very smart person, right? So within the given time still you achieve this quality, right? So that is very important, right? So it's something like this. A person might say, okay, I am going to get an A plus for my project, but I am going to do it in 2 years, right? Because I want to get the A plus, I am going to do it in 2 years. No, that is not good, right? So what I need is you do it in your first year, 1 year, and get a A plus. So that is what is project management. So that the kind of people are the people we need in the industry, right? Because you can't ask from a customer, I need 2 years, 3 years to do that. Customer will say, no, I don't care about that, and then I will get into another team and I will get some reasonable product. I can't wait for 2 years to get my project done, right? So those kinds of things you have to manage. So that those are the things that we discuss under project management. Okay, right. So the result of proper project management is we have better chance of achieving our objectives, overall objectives, and better productivity because we do things in a very systematic way. Better quality because remember we are managing the quality as well, and better satisfaction to the team and the customer. Because when things are not messy, when things are done in a very systematic way, your life is going to be really good, right? Because you do things in a very systematic way, and your customer is also very happy because the customer knows that things are smoothly operating and he is getting the expected releases with high reasonable quality within his budget also. So everyone is going to be happy. When things are managed, everyone is happy. When things are messy, everyone is upset. Okay, so that is very important, right? If your project is in really terrible situation, that means you have not properly managed it, right? Okay. So other than those quotas, software project managers or project managers has to attend some other task as well, right? So for example, they have to do estimating, preparing project proposals, planning and scheduling, right? Risk management, HR management. So likewise, they have to attend some other task as well. Okay. So let's take one by one. So for example, estimating. So they have to do some estimation upfront. Sometimes still the project is you haven't won the project. You are just bidding for the with the customer, but when you are bidding, you have to say that okay, this is our total cost, this is this much of time we need. So in order to do that, you have to estimate, right? So you have to understand their basic requirements, the scope, then you have to come up with size estimation, what size of product we are going to work on, right? There are some concepts like function points, lines of codes to do that kind of estimation. Then you have to do the effort estimation, what kind of effort we are going to have, right? Because software development is all about human effort, not we can't automate things. Then the time required, right? Because we are going to say in the proposal we are going to do it in 4 months or we are going to do it in 6 months, right? So you have to do that estimation. So usually at the beginning there is no team, only you are, only project manager is there, or most of the time these estimation and preparing project proposals, those are done by project manager and architect, and sometimes the help of the quality assurance lead, right? So these three people together and prepare the project proposal, and they have to come up with estimate. So the estimation, your architect will say, okay, I need this much of a effort for development. QA lead will say, okay, I must this much of effort for the testing. So your project manager is going to sum those things and add some project management effort as well, and that is how you do the effort estimation, right? Then you have to do the time estimation. So for that you have to identify the dependent task, exist of course the time management we are going to do it in your project management subject. There we are going to discuss how to do those things, right? Estimate the time, estimate the time. Then the cost estimation. So we have to think about the cost of a software engineer, cost of an architect, right? So depending on their salary, then you have to come up with the total cost for the project. Then we have to apply our profit margins, because we are not going to do it for the only for the cost, right? So we are going to add the cost profit margin, maybe it's 50% or whatever, 75%, sometimes even we apply 100% profit margin as well, because software projects are highly technical nature, right? And we give the estimate to the customer, right? So customer is going to look at different estimates, and of course the proposal will have different things, evaluate your past performance, then only they are going to decide whether they are going to work with you, right? Right. So as I told you, then after estimation, we have to do preparing the project proposal, right? Preparing the project proposal, and sometimes, not sometimes, most of the time you have to go and do a presentation to the customer also, because customer want to see exactly how the things are going to be done in your organization if they are going to give it to you, because still remember it's a proposal, right? Still the customer has not agreed with you, because customer is looking at possibilities, right? So as a project manager you have to work with your customer and get his attention and get his confidence, okay? Then they have to do the planning and scheduling, right? Project managers has to do planning and scheduling. So they have to there we can use things like PERT charts, right? Gantt charts. So I'm not going to details, so you have to be aware of those things. There are some details in the handbook, right? So you have to be aware that these kind of things will be used. So this is used to identify dependencies and schedule your tasks. So anyway, we are doing this kind of lot of in detail in your project management subject, okay? Then project managers has to do risk management as well, right? Because risks are always there when it comes to handling a project. Risk means a possible bad thing. If the risks are not properly managed, you are going to have some issues, right? You are going to have some issues. So that is bad thing has already happened, right? So you can see that in health you always have the risk of your teeth getting deteriorated or whatever, getting bad. So that is a risk. So you, that is why you want to manage it. So how to manage it? You reduce your consumption of sugary things, you brush your teeth every day, right? At least twice. So that is you are trying to minimize the risk. If you are not properly managing that risk, after sometimes you are going to lose your teeth, right? One by one. So that is, now you are having issue. Now you can't chew something, you are having always some pains, that is issue, right? So people who manage the risk are going to have less and less issues. Same thing in the project also, you are going to have some risks. So what are the possible risks? So the biggest risk that every project manager is having is your best person leaving your organization. Actually, that is the biggest risk every project manager is having. Your best software developer, your best architect, will he leave my organization and join another one? Right, so because there are high opportunities for good people. Of course, the bad people, they are going to with you forever unless you kick them out. So in that case, of course, he is going to think about how am I going to kick this guy, because he is a terrible person to my project, right? So that is a risk. Then there can be risk related to customers, right? Because the customers may have their own thing. Then there can be risk related to selection of technologies, right? So we have selected a particular technology, is it going to really going to work with us, right? So stuff like that. So those risks we have to manage, right? Then a risk of accepting too many changes, right? So likewise, project managers has to think about those, and handle those risks, otherwise things are going to be issues, right? So that is firefighting, right? Fire has already erupted, so we don't want that to happen in project. Okay, right? So that is also important. Right? So this is the risk management process: identify risk, analyze risk, plan risk, and monitor risk. Okay. So I'm not going into details because this is a quick revision. Then there are some risk management tactics also, right? The avoidance, mitigation, transfer, acceptance. Right? Avoidance, mitigation, transfer, and acceptance. Okay. Avoidance means we try to avoid that risk. Right? That is the best thing. Right? That is the best thing. It's something like we try to avoid losing our teeth. So that is the best thing we can do. Right? So that is called avoidance. So that means we try to avoid my best software engineer leaving my project. So that is avoidance. So that is why we always give him a lot of facilities, high salaries, etc. Right? We want to avoid that happening, because he is a very crucial person. He is a very productive person. He is driving my project, right? So that is risk avoidance, right? Again, I want to avoid the risk of my customer losing interest about the project. So that is why we want to give frequent releases, right? High quality releases. Then he is going to be really, really with me, right? So that is avoidance, right? Mitigation means we try to minimize the risk, right? So we may not be able to 100% avoid it, but at least we want to minimize it. So that is called risk mitigation. Risk mitigation, right? So there are some things that we can do, because most of the time it's very difficult to avoid the risk. Most of the time what we try to do is mitigate the risk. Mitigate the risk. Okay. Then we have the risk transfer. So risk transfer means we transfer risk to another party, but that is very rarely we can do when it comes to software development. So very good example of in real world scenario, I'm not talking about the software development. Risk transfer is taking insurance. For example, why you want to have a vehicle insurance? In case, because there is always risk of your vehicle get collide or facing accident, right? Because especially in this kind of a society where no discipline, very low quality people are there, right? So we are living in a very low quality society, right? So no discipline, and also there is no discipline. So in that kind of situation, always we go for insurance, vehicle insurance. Why? We want to transfer that risk to another insurance company, right? Because we just pay about 50,000, 60,000 per year. In case there is a heavy accident, they are going to pay us maybe 3 lakhs or 4 lakhs or whatever, right? But there is a cost for that also, that we have to pay that installment or premium. Okay, so that is for risk transfer. Of course, very rarely we do that kind of thing in software development, but in general that kind of things are there. Okay, risk transfer. Then risk acceptance. So the risk acceptance means we accept the risk. We accept the risk, and we plan out how to live with that risk. If that risk happens, we have a plan how to tackle it, right? So that is called risk acceptance. Of course, sometimes what we do is we do all four together, right? So we try to avoid, we try to mitigate. Of course, very rarely we can transfer. At the same time, we have planned in case of that risk occur, I am going to act like that. For example, if I am, of course, I try to keep my best engineer in my project, right? I try to minimize him leaving my project. At the same times, I might be preparing another engineer in case that person leave. I am going to use this my second option to fill that gap. So that is because in reality I can't keep person forever, because he has his own aspirations, right? His own career objectives. If we feel like the other company is going to give him better opportunities, he is going to leave it, right? So then I have alternative, right? So that is called risk acceptance. Okay. Right. So finally, we are going to discuss about little bit of the human resource management. So when it comes to human resource management, it's a really challenging task. Why? We are managing professionals. So in a way, managing professionals are really easy. In a way, managing professionals are really difficult. Right? So really difficult. හරි ඔයාට කිව්වොත් එහෙම ඔයාට මැනේජ් කරන්න ඔයා කැමති හරක් පට්ටියක්ද ප්‍රොෆෙෂනල්ස් ලාද කියලා සමහරු කියයි හරක් පට්ටියක් කියලා. So right, සමහරු කියයි ප්‍රොෆෙෂනල්ස් ලා කියලා. If you are not smart enough, right, if you are not smart enough, you like to manage dumb people because they are dumb, very easy to manage in a way, right? The smart people, if you want to manage smart people, you must be a smarter person, otherwise you are going to be a joke to them. You are going to be a joke to them because these people are highly talented, highly smart people. You try to manage that set of people and you are not that smart, so that is not going to work. So therefore, that is why I say in a way this is more challenging. So you have to be very smart person to win the confidence of your team members, otherwise you are going to be just a joke, right? So that is what the reality in a lot of software projects in Sri Lanka. In a lot of software projects, the project manager is a joke. So I am talking the reality, right? The thing is, if you are really good at software development, right? So just keep it in mind, right? So you are a really good programmer, you are a really good software engineer, you have a really good attitude. So from day one, you are going to enjoy your life as a software engineer, right? From day one, right? So because you like your work, you like the challenges you are having, right? So you are really like what you do. So therefore, you are not thinking about becoming a project manager. Why? You are really comfortable with your task, right? You are really comfortable with your task. Now assume another person, he somehow managed to get into the software development company, but he is not that good person, right? He is not good at coding. He don't like facing challenges at code level. His mind is not really working well to come up with really smart solution. So what he is going to do now? From day one, he is thinking of how to become project manager, right? How to become a project manager. Why? He is uncomfortable doing software development, right? So from day one, he is try to become a project manager. So the real good person, he is comfortable, he likes what he is doing, he is not thinking about becoming project manager, right? So therefore, what happens in some cases, that bad guy become a project manager because he is always eyeing at becoming project manager, right? So what happens is then all of a sudden other people recognize that okay, this bad guy has now become my manager, right? So he don't know how to code and he is now telling us how to code, and he is now telling us have you achieved your objectives? So then he is going to become a really a joke for you, and also you are going to resist him, right? Your team members are going to resist him. So that is an eternal conflict between software engineers and project managers. I am not saying that every project manager is like that, right? I am not saying. I am saying that that possibility is always there. That possibility is very high when it comes to Sri Lanka, right? When it comes to Sri Lanka, right? So therefore, that is why in agile software development, we even get rid of this concept of project manager, and we have the scrum master. So scrum master is a coach, right? Scrum master is a coach that is going to work very closely with you, right? So if you are not really good, you don't want to be a coach, right? Of course you can be a manager, but you don't want to be a coach, right? So then your really good people will become your leaders. So that is really important. That is really important when it comes to software development field. If you are planning to have software development business or software development organization, make sure that always you pick your best person to be a manager. Otherwise your team members are going to resist him, right? They are going to resist him. Okay, so that is very important because HR management is not that easy when it comes to managing professionals, right? So it's not like managing set of donkeys. Okay, right? So we need few points here. So we need the honesty, right? Consistency and respect. So those three are really very important. So you must be very honest when it comes to managing your team members, right? So you must be very honest, and also you must have very good consistency. So you can't treat different people in the same situation and two different ways, right? So you have to be very consistent. Of course, if there are any personal issues with a person for a short term, you have to cater for that. Otherwise you must be very consistent. Then only other people are going to trust you, because they know that you are not favoring anyone. Okay, That is very important, right? Then the respect. So of course you are the manager or you are playing a leadership role, but you have to be very respect. So that is the difference between leader and boss. So if they feel like you will act like a boss, they are going to resist you. Actually, most of the time, so one of the thing that every field having is most of the time people leave the boss, not the organization. So they frustrated with their manager, not with the organization. So when you have a bad manager who is a bossy person who does not respect others, the people are going to leave the organization, right? So they are okay with the organization, but they are not comfortable with the manager, but they have no option. They can't leave the manager. Therefore what they do, they leave the organization and join another organization. So that is why we need really professional, right, people in the project management level, right, management or the coaching level, right? So very important, honesty, consistency and respect. Okay, right. So that's it for that. Then what are the tasks that HR management has, like hiring, right? So they have to interview and get the best out of best people and make sure that they don't get any bad people, because that is going to be a real headache. And it's always really complex to throw people out of the organization in countries like Sri Lanka. Therefore hiring is a very important task. Managers have to do training, performance of evaluations, right? So every year there will be evaluation cycle to see which kind of a player you are, whether you are A player, B player or C player, because depending on your ratings you are going to get the increments and promotions, right? So A players will get higher salary increments, B players will get lesser increments, C players will might get small increment or sometimes no increments. Okay, right. So then the career building. So we want to take care of each and every team member's career because they have their aspirations, right? Then of course the welfare of the employees. So that is why we have outings, right? So trips and some other welfare things, benefits given to them. So those things also at management level we have to think. Okay. Right. So that's it. So I didn't cover everything, but I hope I covered most of the important things, right? Important things in your syllabus. Right. So what I'm going to do is I try to do at least one paper very quickly. Okay. So because all the papers are pretty much the same thing. Let's move on to the past papers. So let's do the 2019 paper. So other papers, of course, you can do by your own. If there are any questions or ambiguities, you can ask those things in the WhatsApp group. Okay, right. So let's do the MCQs 2019. We'll try to do the 2019 paper only. Okay, right. First question: which of the following is are not characteristic of software? Right. So they are asking about not characteristics. Okay, I will just zoom it properly. Right. So I hope you can see it. Right. Configurable, tangible, maintainable, wearable, portable. Now we discussed this in the very first one or two slides, right? So we know that software is so let's take the pen. So can we configure software? Of course, yeah. So that is why we have the customization. You can now remember I just do some configuration to this PDF, right? So I can, you can see I can zoom it. So that is configuration. So that is not something you have to learn in your theory. That is common sense, right? That is common sense. You can configure. You can configure, right? I can go to another mode. Likewise, customization you can do, right? You can increase the font size. You can disable some functionalities. So that feature is there because it's a software, so that means that is yes, what they ask is not one, so that is configurability is there. Software is not tangible, so that is obvious. Software is not a physical thing. Yes, software must be maintainable, so that is something we want to make sure, right? Maintainable. So software does not wear away because it's intangible, so no. Software, yes, they are portable. Of course we want to make sure that softwares are portable. Okay, so what they ask is not correct, so the answer is B and D. B and D, right? So I have the answer sheet with me. Therefore, I'm not going to show it again because to save time. The answer is B and D, correct. Okay. So let's move on to second one. So once if you have understood, you can just go to the exam very relaxedly, right? So don't just memorize or recite and go there. It's no point for you, no point for the society. You are going to be just a degree holder having no character, right? Nothing, right? Nothing. So I'll just little bit increase this. Right. So second one. Which of the following types of software is used in modern self-driving car? Right. So that's common sense again. So I like that kind of questions because it check whether you have understood the concept. Right? Self-driving car. Now remember, Google is testing self-driving car. Uber is testing the self-driving car. They are doing now live testing. So you have to be aware of those things, right? If you are in software engineering field, right? So they are now doing their live test. So therefore, you must have read something about those things if you are really interested about software engineering field, because those are the things that real software engineers are right now doing, right? Right. So let's see what are the things that the self-driving car is going to have, right? A, application software and web-based software. Of course, self-driving car is going to have some sort of application softwares like navigation, support navigations, etc. But I don't think it's a web-based software, right? Because we are not going to use self-driving car as a web-based application because it's a real world product, right? Physical product, right? So it's not a web-based application. Of course, if they are talking about online banking, online purchasing, so that is web-based software. Now you can see self-driving car is not a web-based software where we go to the website and use the self-driving car, right? So if it is a game, of course, yes. So therefore I will not take it. It's not a web-based software, right? It's sort of a robotics. System software and AI software, right? AI software. So yes, right? So it's going to have some system software. So it's going to have some operating system, right? So obviously, so even small applications have system software, and of course, yes, it is going to have AI software. So for me, that is an answer. That is an answer, right? So obviously it is AI because self-driving car you can't do it in a normal programming way because it's going to encounter the new situations every moment, new situations. That is where we need to have AI software, right? So for me that is the answer, but in your paper they have not taken it as answer. See, embedded software and system software, right? Embedded software is software embedded to a machine, right? Machine. So most of the time, if you take elevator, right? If you take something like washing machine, you have embedded software, right? Embedded software. Uh, so it's a very debatable thing. If you want, you can take it as a embedded software as well because you have your vehicle. To embed it to the vehicle, we have the software. So that is, I don't know, but it is more than embedded software when it comes self-driving car because it's doing everything self-driving, right? Without the help of anything, it's doing its work. So it's debatable answer. System software, of course, I like to have it because it is going to have some sort of operating system. For me, I like both the answers. Okay. So third one is AI software, obviously yes, and embedded software, yes, right? Embedded software for me, yes, right? For me, yes, and the answer sheet they have taken that as a answer. Anyway, then the business software and customized software. I don't take it as a business software. Business software means something like order processing system or whatever. Someone, if you want, you can say that okay, there's a business involving, but I don't take it as a major business software. So I don't like that answer. So my answer is B, C, D, but your examiner's answer is D. So that means only D. Now that means he has taken it as embedded software. Right? He has taken it as embedded software. Only thing is he thinks that it doesn't have system software. But I think every vehicle is going to have operating system. Right? Right? If your smartphone is having operating system, I don't believe that your self-driving car is not having operating system. Right? So therefore for me B, C, D. but in your answer sheet it is D. So sort of a debatable situation. Okay, so that can be, that kind of situation can be there. Third one, which of the following are the two most important non-functional requirements that the system in a modern self-driving car must uh, process or possess means have. Which of the following are the two, so I will take the pen again, most important non-functional requirements, right? So they are talking about the most important, not just important, when it comes to self-driving car must possess, right? Right, so user friendliness, portability, accuracy, interoperability, efficiency. Again, this is a very very open question. There can be a lot of disagreement, there can be a lot of disagreement because two people will look at it in two different ways. So that, don't worry about that. So again I am saying, if you want to get A plus, this is not the subject. If you want to get the A plus, go for the maths, because so that is where a lot of people get A pluses, because in this kind of papers there will be a lot of disagreement with you and your examiner. So that is actually natural thing, right? I am not taking it as bad thing. That is a natural thing. Of course, if it is very obvious, I will get little bit upset. But so that is the nature of this subject, right? So therefore, let's. So I am not looking at the answers actually, right? So let's. I will give my opinion. You can have your opinion also, right? There can be some disagreement. So that is really natural for this kind of a question. Okay. So user friendliness. So I don't think it's a big thing because self-driving car is going to do the self-driving. I just have to get into that and get off and just ask the self-driving car, I want to go there. I don't know whether you have heard that joke, right? So I don't know whether you have heard that joke. Now remember, when you get into your vehicle and when you are driving, right? If your mother is in your vehicle, you are in trouble now, right? Especially if your mother is in your vehicle. Why? Your mother is going to give you all the instruction in the world how to drive, right? How to drive, right? So she will say, okay, slow down, right? So there's a vehicle up there, so you when she is not there, you are doing all the, you are aware of all those things, right? So same thing might happen to self-driving car. If you try to give him all the instruction in the world to the self-driving car, your self-driving car is going to piss off. Okay, so anyway, so that's just a joke, not a joke actually, reality. So say, I don't know whether self-driving car is also going to face that kind of situation, right? But anyway, so I don't care, I don't think that user friendliness is a really really big issue, right? Anyway, let's see. Portability, do we want to port our self-driving car? I don't think so, right? I don't think so, because because I don't think that I want to port it to another operating system or whatever, right? I don't think that that's a very big issue. For me, accuracy is really important, right? Accuracy is really important, right? Because I don't know whether we can take it as a functionality, non-functionality, but that is the most important thing. Otherwise there are going to be a lot of accidents and a lot of issues, right? So I like that answer, but I doubt whether it's really a non-functional, but if you want, you can take it. Okay. uh, Interoperability, so operate with other systems, right? So in a way that is going to be very important, because it might be using a Google map, or it might have to use another map, right? Or it might has to use some sensors with traffic operating systems. Now remember, when the Google drive, when the self-driving car comes, the we need to upgrade our infrastructure also, right? So rather than just looking at the traffic light, if we can, if our traffic light can sense or communicate with self-driving cars directly, it's more accurate, right? So therefore the infrastructure is also going to be upgraded as part of the emerge of self-driving car, right? So gradually, so I like that answer also, interoperability, right? Efficiency, of course we like to have that fuel efficiency and those things, but I don't like it as a part of the self-driving our information system. That is something to do with the mechanical system, right? uh, of course efficiency, if it means it has to take quick decisions, I will go with that, because quick decisions are really needed, right? Quick decisions are really needed, so therefore this is a debatable answer. So actually, out of three, now we have to pick two. It is most important. I will go for C and D. I will go for C and D. Now I'm just checking the answer, because it can be always disagreement. Very open question. Okay. Right. So the answer in your sheet is C and E. Now you can see out of these three, I went for C and D. Now your examiner has picked C and D, E. So he thinks that more than interoperability, efficiency is important. I think his thinking is if you are doing those quick, efficient decisions only, it is going to be accurate. So I like that thinking also. Therefore, now I feel like the examiner has a better answer than me, right? Because if they are really efficient only, it can do those accurate decisions also. Because otherwise, it is taking the correct decisions, but by the time it's taking the decision, you can see I was moving like the fuel efficiency, etc. But the examiner is thinking about the efficiency of processing. So in that case, yes, efficiency is very important. So I like his answer more than my answer in this case. Accuracy and efficiency. Okay, accuracy and efficiency. Okay, right. So let's move on. Fourth one. So you can see this. There can be some interesting questions. So we can have agreement, we can have disagreement. So that is part and parcel of life. Which of the following would be functional requirements of a hotel room reservation system? So now they are talking about what? Functional requirements of hotel room reservation system, not non-functional functionalities, right? Guests can make reservation for the room. Of course, it's functionality. The user interface should be easy for users to operate. No, that is a non-functional requirement called usability. Availability of the room should be displayed before booking. Right, so is it a functional requirement? I think yes, right? So that is a functionality we need. Whether it's available or not, it has to be shown. I will take it as a functional requirement. The system response time should be fast. So that is non-functional requirement called efficiency. The system should be secure enough such that the members' personal data can be safely protected. So that is security, right? Security. So I will not take it because security is a non-functional requirement. So for me, A and C are answers. In the answer sheet, only A is the answer. Right? Only A is the answer. So the examiner has not taken this as a major functionality. Right? So he may be thinking it as a something like user friendliness or something. For me, it's a functionality. It has to show it, right? So anyway, that's a sort of a debatable answer again. Right? So what your examiner has taken is the major functionalities, right? So reservation, cancellation of reservation, payment, etc. So he thinks that this is just a small part. Again, debatable. So I really like to have this also as a functionality, but he thinks that this is just a small part. We can't take it as functional requirements. Again, you may agree with me or you may agree with the examiner. So that is okay. That is okay. That is part and partial of when it comes this kind of subjects. Okay, right. And of course, you may have some different answers as well, right? So if you have some different answers, let me know. Let us know. Okay, so we can discuss that also, just like we discuss the answers. Right. Fifth one. What languages among the following can be used to develop business logic of a bespoke software? So what is mean by bespoke software? Custom made software, right? Software specific to a particular customer. We discussed those things in your semester one, right? Right. So again, let's see whether we have agreement and disagreement. Right. Of course, I can use PHP. I can develop a system to my customer using PHP. Right. Then I can use XML when we are developing a bespoke software. Right? For me, that is okay. But usually we use XML when we want to communicate or interoperate with other parties. But we can use XML even to communicate between our own components as well. Right? If we have another software in our company, I want to communicate with that software. I can use XML, right? So even I can use XML when it comes to Ajax calls. So therefore, I go for XML as well. Right? Of course, HTML I can use in the client side. I can use Java. Okay, no, sorry. Now look at this business logic. Now I forget that. So that is why I'm always highlighting in the exam also. You best thing what you have to do is what? Highlight. After otherwise what happens? After 1 second, 2 seconds, again you lose it. right? Because you are in a high pressure, exam pressure also. Now look at it again. It says business logic, right? Business logic. So for business logic, you can't use XML. You can't use XML. It's all about data transferring, right? So therefore I'm going to remove this, and I'm going to remove HTML also. We know that for business logic we don't use HTML. It's all about presentation, right? It's all about presentation. Of course we can use Java if it is a backend is Java. SQL we don't use to do business processing, right? SQL is to query the database, insert, update. So don't use SQL. Of course you can do little bit of business process logic if you are using PL/SQL. So that is stored procedures and functions, right? So if that is the case, but that is not a recommended way, therefore I don't like to go for SQL, but I don't know whether examiner might take this as answer. In that case I have to agree with him, but I really don't want to go for SQL. I prefer PHP and Java only. So I will double check the answer and let you know. 5. Yes, answer is A and D only, right? A and D only, because SQL is more into the database communication. Okay, so A and D, right? You can see if you lose this term business logic, you are going to, most of the time you are going to answer all of them as answers, right? So that is why it's very important you read your answers questions properly. Okay. 6. Which of the following is are not an activity in software process, right? So we discussed the general activities in software process, right? What are general activities? Specification or analysis, design, develop. Of course if you want you can have the implementation or deployment. Of course before that you have to have the testing and evolution and maintenance, right? Evolution and maintenance. Now let's look at the answers. Evaluation, what they're asking is not one, right? So there's nothing called evaluation. What we have is what? Evolution. Evaluation means evaluate your thing. That is something like customer can evaluate your product, right? So that is not a part of the software process, main process. So this is not something, but yes, specification, no analysis is there. Abstraction is object oriented concepts, right? So that is not something like that. Then we have the validation. So validation is not a, of course we do do testing to do validation, but that is not a major activity. So activities are specification or analysis, design, develop, test, right? Or if you want you can take maintenance and deployment and evolution. So I will not take validation. Of course evolution is their final stage that we discussed today also. So what they are asking is not, right? Not, therefore I will go for A, C and D, right? A, C and D. So in your answer it is A and C. A and C, they have not taken D. So they have not taken D. Again there's a small disagreement. So your examiner has taken testing and validation as the same thing, right? So of course so that's debatable. Yes, so we are doing testing to do validation, right? We are doing testing to do validation, therefore indirectly your examiner has taken this as a correct one. So therefore he has taken has testing and validation as synonyms, right? Of course we do testing to validation, therefore uh, his thinking is somewhat okay, but that is not the real world. So this is the phase is testing. Why we do testing? To validate, right? So what they ask is activity. Activity is testing. Why we do testing? To validate. So I don't know. According to him, he or she has taken validation also as a answer. So it's somewhat okay. Little bit of disagreement again. Okay, but indirectly yes, validation is also doing testing. Right. Right. So next one. 7th one. So there is a bit of raining here. If you hear some sort of a background and if it is too much, let me know. Okay, I can move to another room and do it. Otherwise, I hope it is not a big background noise. Okay, right. Whom among the following is are not and actors of the use case diagram of a typical banking system, right? So this is something to do with the object oriented programming, right? So who are not the actors? Actors mean the people who are going to use it, right? System and QA engineers, of course they are not going to be actors, they are just involved in development, right? So what they ask is that not people. Customers, of course. System administrator, yes, because system administrator is going to interact with the system to do some user management, etc. Right? Bank manager, obviously yes. System developer, no. Right? So they are just involved in development. So they are asking is not, that means A and E. Right? So I will double check the answer. Yes, answer is A and E. Answer is A and E. So that is straightforward question. Let's move to the eighth one. What is are the most suitable process models among following to build a flight control system? Now again, it's a very critical system, flight control system, so a mission critical sort of a system. So they ask you which process model is going to suit for that. Of course, you know that for this kind of mission critical system, the things like rapid software developments are not going to work. Okay, uh, right. So let's see. What is are the most suitable process models following to build a flight control system in the modern aircraft, right? So it's a aircraft flight control system, right? So it's a very mission critical system. If there is a small bug, we are going to lose lives, right? We are going to lose hundreds and thousands of lives. Okay, right? So let's see. Extreme programming, definitely no. Extreme programming means very high quick releases, right? So quick releases in quick time. So we can't develop that kind of a thing in that way, right? Prototyping. So it's a, again can or cannot be. Initially we might create some prototype, right? Because a flight control system and then keep on improving. But again it's a very debatable. I don't want to go into prototyping, but there's that possibilities also there. Sometimes we can just come up with a prototype because that prototyping possibility is always there. So it's a bit of yes or no. So I don't know, right? Then rapid application development, I don't want to go for rapid application development because it's a mission critical system, right? Next one, waterfall model. Yes, for this kind of a thing, yes, right. For this kind of a thing, we want to do things in a very systematic way. We don't care about the time spent much because it's very critical system. I will go for waterfall for this kind of a system. Right? I will go for waterfall for this kind of system because customer is not asking for quick releases because he is not going to use this unless it is 100% done. Right? No one is going to test in real world your half built flight control system, right? So I will go for waterfall, yes. Scrum. So scrum is again a something like extreme programming, very agile development where we give quick releases. I don't want to go for that. So for me, I'm not sure whether B is an answer or not, right? But D is the answer. D is the answer. Now let's see the answer sheet. Answer sheet says B and D. So you can see they have taken B also because B prototyping can be used because it's something like throwaway prototyping most of the time, right? So actually it must be throwaway prototyping because we don't want to go for evolutionary prototyping as well, right? Because it's a very highly critical system, right? So anyway I will settle for B and D, right? So I assume this is pretty much a throwaway prototyping, right? So as I told you, now you can see it's not that easy to get an A for this subject, okay? Especially for MCQs because there can be disagreement. So easiest way to get A is do some your programming, right? Maths and maybe object-oriented SAD also, that not that difficult because this is fuzzy. Disagreement might be there, okay? Right. Question 9. In the spiral model, risk analysis is performed. So that is just checking your memory, right? Memory. So you have to aware of the which stage the risk analysis is done. I just rushed through those things only. So the answer is D. Risk analysis is done in every loop. So every loop, at the beginning of every loop, every cycle we do the risk analysis, right? We do the risk analysis, right? Because it's a never ending task. Okay. So 10. What among the following is are not phase of unified process? Remember we discussed that, it is mentioned in your slides also, right? So in our we discussed that. So what are the phases in rational unified process? So in general we say unified process: inception, elaboration, construction, and transition, right? So then let's mark what are the answers. Elaboration, yes, right? There is nothing called evolution. Remember, evolution is part of the standard software development activity, but in rough we don't have something like evolution, right? What we have is transition, right? So transition is there. There is nothing called validation. There is nothing called specification. So answer is A and C. A and C. Okay, so they have taken E also. Sorry, what they are asking is not correct one. So the answer is B, D, and E. B, D, and E, right? So the answer is not correct one. So B, D, and E, right? So the answer is B, D, and E, because elaboration and transition are part of the phases. Remember what are the phases? Elaboration, construction, right? Transition. So those are the phases. Okay. So let's look at it again. So we discussed those things in the very beginning. Software development process models. Now this is the spiral. Now you can see inception, elaboration, construction, transition. Right? Inception, elaboration, construction, and transition. Inception, elaboration, construction, and transition. Right. So let's move on. 11th one. Which of the following is an agile software development method? So what are the two agile software development methods we discuss? Extreme programming and Scrum based, but there are some other agile approaches as well, right? Other agile approaches as well. Abstraction is object oriented concept. Okay, so that is not answer. Spiral model is a traditional approach. Yes, extreme processing is there. Prototyping is not an agile approach. Remember, Kanban is agile approach that we didn't discuss because it's a very quick revision. There are some other things like Kanban is there, lean development is there, right? Likewise, there are few more agile approaches as well, right? Other than the extreme programming and Scrum, right? So you can see if you have read a little bit more about agile development, you can do this particular question. So Kanban is one of it. So another one is called lean, right? So there are some other few also. So the answer is C and E. C and E. Kanban is also there. Okay. So that anyway you are going to learn these things under in next semester. You have the rapid software development. So what the examiner does is he is just checking whether you are aware of these things also, because he want to control. Otherwise, everyone is going to get A pluses. Okay. 12. Which of the following is a part of the requirement engineering process? So requirement engineering means requirement analysis and modeling and those things. Okay, right. So let's look at it. So there's nothing called requirement design, right? So requirement is one thing, design is another thing. So this can't be, right? So requirement specification. So yes, right? So basically what we want to do is what? Specify the requirement. So there is nothing called requirement manipulation. Manipulation means you are doing some underhand things, right? Manipulate කරනවා කියන්නේ නිකන් ඒට මේට කරලා මේව කරනවා. Right? Requirement evolution. Actually it is not the requirement evolution of your product, right? Evolution of your product. So therefore I will not go for that also. Requirement validation, yes. Yes. So what are the basic things we do? Gather requirement, analyze requirement, model requirement, right? Then document requirement, validate requirement, right? So we mentioned those things in your slides also. So but overall we can say end of it is specification. So therefore they have taken the specification as well, other than we have the validation. So they have not mentioned about the gather, analyze, document, etc. Okay, so the answer is B and E. So the answer sheet also answers B and E. Okay. 13. Which of the following statement is are true? Requirement analysis is not so critical to the success of the development project. So that is wrong. Requirement analysis is very critical. If you made a mistake here, that mistake is going to drag through to the next level, next level, next level. Now your design is wrong, code is wrong because your requirements are wrong, right? So not so critical. Sorry, not that is wrong. That is wrong. It is a critical thing. It is a critical thing. B. Functional requirements are constraints on the services or functions offered by the system. No, that is not functional requirements, that is non-functional requirements, right? This is the definition of the non-functional requirements, right? So that is wrong. That is wrong. C. Requirement should specify what and how. No, right? So requirement must specify what, right? I don't know how is something that we do in the designing, right? So the user say I need this, and sometimes he will say I need it like this way also, right? So it's a debatable thing. Most of the time what we interested is what you want to do, and sometimes we will ask how you want to get it done. But if it is a, so it's a debatable thing, right? Basically how is mostly design, I don't know. So it's a 50-50 sort of situation, right? Right, the way you look at it, it might be different, right? So I don't know, it's an open thing. Non-functional requirements specify the system's quality attributes. Yes, right. So remember we give that thing, it specify the quality attributes, and also it specify the constraints on the services and functions, right? So that is correct. It's a quality attribute. Ethnography is one of the software cost estimation techniques. So ethnography means what? You observe how the people are doing the stuff, right? So that is not a cost estimation technique, that is a requirement analysis technique, right? So D is the answer, C is a debatable thing. Okay, so let's see the answer. 13. So they have taken only D. They have taken only D. Now you can see that they have taken only D because how is more into the design. What? So we only concentrate on what in system analysis. How to do that is something we do in the design, right? So therefore, so of course the customer might say I need to get it done like this, but we consider it as a design aspect, not the analysis aspect. So you can see the answer they have taken is as D. So actually I like that answer because C is not there, right? I will just doubt whether C will be there, but yes, I think examiner's answer is really the valid answer. This is not good, right? 14. What is an object-oriented concepts among the following? So that is very simple questions if you are aware of object orientation. So validation, no. Modularization, it's more into the structured programming. Evolution is a process model thing. Abstraction, yes. Come is a process. I don't know whether the examiner will take B, right? Because the main concepts are abstraction, encapsulation, inheritance, polymorphism, right? Abstraction, encapsulation, inheritance, polymorphism. Modularization is more from the structured programming, right? Of course, we have a little bit of modularization when it comes to packages, etc. It's a debatable answer if it is there. I will go for D only, right? So let's look at the answer for 14. They have taken B and D, so that means they have taken modularization as well. So I can't argue with that answer. Though the main concepts are abstraction, encapsulation, inheritance, and polymorphism, modularization is a concept that comes from structured programming, but still we can use it. That is why we have a concept called packages, etc. So therefore, yes, I have to agree with that answer also, right? So though we don't talk it as frequently as other things, if you want, you can take it as answer, right? Because that is also very useful feature. So anyway, we'll go for B and D, right? B and D. So in the future also, if they ask the same question, go for modularization as well, okay? Because that is also a very important aspect, though we don't frequently talk that together with others, okay? 15. So it is not just giving you the answer. So that is why I'm taking some time. I'm giving you how to think in this kind of situations, and also if you can try to reverse engineer your examiner's mindset also, because if he is going to create the next year's paper also, if you have very good idea about how your examiner is thinking, you can be very smart marking your answers, right? So sometimes you will think like him and answer MCQs, because in this kind of subject, if you can get into his mindset, it's very productive for you, right? Because there can be disagreement. Then though I disagree, I know that my examiner is more like this kind of a thinking person, therefore I will go for that. So that is needed for this kind of subject. That is not needed for something like mathematics or programming. But for this kind of theory subject, if you can understand your examiner, it's going to be really helpful for get high marks, okay? 15. Which of the following is correct? Right? The complexity of program depends on its modularity. Right? Yes, right? So if you have so many modules and if they are not properly modularized, it's going to be more complex. If we have less modules and there's a less dependency, that is called the cohesion and coupling. So the yes, complexity depends on the coupling. So right, program depends on its modularity. Yes, if it is highly cohesive and less coupling, that is less complex. If it is highly less cohesive and highly coupled, it's more complex. So I will take that as answer. Modularity facilitate maintainability. Yes, so when you have well-defined modules, it's easier to maintain. Yes. C. Encapsulation allows several objects in a class hierarchy to have different methods with the same name. So that is not encapsulation, that is called overloading. Right, overloading. So that is not something to do with encapsulation. Cohesion should be minimized. So this is coming from your semester 2 programming, okay, and also object-oriented system analysis and design in your other subject. That is why we didn't discuss those things. Cohesion should be minimized. No, cohesion must be high, right? Cohesion must be high. You must minimize the coupling. The system model based on a shared database is called repository model. Yes, so that is called repository model. We have shared repository. Other systems communicate with that. Yes, so that I will take. So for me, answer is A and E. So I will check the answer with sorry, A, B, and E. The 15 answer is yes, A, B, and E. Right? A, B, and E. Okay. So let's move on to the 16th. What among the following is encapsulated in a class object? Right. So what is encapsulated in a class object? We want to encapsulate what? I want to encapsulate both attributes and behaviors, data and behaviors. Right. So let's see the answers one by one. Data. Yes, we want to encapsulate data. State. State is also part of data. I want to encapsulate state. Behavior, yes, I want to encapsulate behaviors as well into methods. State and behaviors, so that is also correct because I want to encapsulate state. State is part of data, right? Then it says both data and behaviors. That is also correct. So now you can see part of the answers are there, whole answer is there. But which one is the perfect answer? The data and behavior. Right? Because this is just part of it. State is just part of data, right? So this is also part of it. When it is state and behavior, data is more than state. So therefore the perfect answer is both data and behavior. Now you are in trouble again. Are we going to answer all of these and we pick only the perfect answer? So in this kind of situation, what we have to do is they have not say exactly or whatever, if they have used that word, it would have been better. for you, help you. But when you have part of an answer and the whole of the answer, usually what you have to do is pick the whole answer only, because they are just part of the answer, right? So therefore, I will go for E. I will go for E because these are incomplete answers. I have the complete answer as well, right? So I will go for E. So let's check the exam answer sheet. Yes, answer is E. Answer is C. So that is how you have to do, right? If you have the part, now you try to understand your examiner also, right? So he will do this kind of questions in the future also. Part of the answer will be there, whole of the answer will be there, then I will go for whole of the answer. But there can be some examiners, they will sometimes go for the whole part of the answers also. They will take it as answer because yes, we have to encapsulate data, right? Right. So that is why I ask you to reverse engineer your, of course, he is not a product, but we want to understand, right? That is another skill we need. 17. Which of the following statements are correct? So that is why when you are setting a paper, you are exposing your personality to the society, right? Right. 17. Which of the following statements are correct? Bad design can correct it through advanced coding. No, bad design you can't fix by coding. Bad design has to be fixed at the design level, right? So that is not going to work. So that is why we said don't make mistakes. Think that okay, I can fix those in the coding. No, so that is wrong. A good design can be spoiled by the bad choice of programming languages. Of course, yes, you have a really good design, but you pick a wrong programming language, right? So that is correct. That is correct. C. The programmer translates the requirements into source code using a programming language. That is correct, right? So programmer translate the requirements into source code. No, not the requirements. What he translate? Design into source code, not the requirements, right? So he get the design. He translate design into source code using programming language. So I will not go for C because it says requirements, right? D. Coding is a major activity compared to the other phases of the development. So that is again debatable answer. For me, every activity is major activities. I can't say this is major activity, this is a minor activity. But for me, requirement analysis is also critical, design is also critical, coding is also critical, testing is also critical, evolution is also critical. So I will not say this is major, this is minor, right? Right. So everything is major. Again, it is debatable. So see, for me everything is major activity, therefore I will say yes, coding is a major activity, right? So I can't say. So basically, if the examiner put requirement analysis is a major activity, I will say yes. Design is a major activity, yes. Coding is a major activity, yes. Testing is a major activity, yes. Evolution is a major, yes. For me everything is major activities, all those are major activities, therefore I will go for take it as answer. Good programming practices help end users to get familiar with the system. So that is two different things, right? So good programming practices and users get familiar with the systems are two different things. So those two are good things, but unrelated things. Right? First one is not going to help the other one. Those are independent things. So I will not go for that. So my answer is B and D. B and D. So I'm just checking the answer. Right. So your examiner's answer is only B. Only B. So he has not taken D. Okay. So now I can see that why he has not taken it as answer. I want to agree with the examiner. Coding is a major activity compared to other phases of the development. So what you can see is that now this answer implies, actually I lost that part. This implies that coding is a major activity compared to other. It implies, what is the implication? It's something like coding is a major activity, others are minor activity. So I kept on telling you that for me everything is a major activity, but what I read is coding is a major activity. Actually I lost this compared to part. So that is why I picked this as answer. I fully agree with the examiner's answer now. Yes, so this is wrong because we can't say coding is a major activity compared to other phases. It implies that other phases are not that important, right? So yes, so answer is only B, right? Answer is only B. So I just lost this part when I read the answer. Okay, right. So let's move on to the 18. What is the correct execution order of following testing types? Regression testing, acceptance testing, unit testing, system testing, and integration testing. Right. So which one we do first? Usually we do first the unit testing. So for me, this is number one. We discussed that. Then we do the system. No. Before that, we have to do the integration testing, right? Regression testing is usually once we do the releases, we have to go for regression testing. So just to check whether we have not broken the major functionalities, then I will go for system testing. Then when we release the product, we go for acceptance testing. When we are doing some changes, then only we are going to do the regression testing. For me, fifth one is this. So for me, answer is D E, not D, C E D B A. So that is C E D B A. That is D. For me, answer is D. Now I'm double checking the answer. 18. Answer is D. Yes, correct. Correct, right? So remember, regression testing is done when we are doing a changes, right? So just to check the overall health, right? Right. So answer is D. Now let's move on to the 19. Alpha and beta testings are form of regression testing, unit testing, user testing, acceptance testing, system testing. Okay. Now again, little bit debatable. It's not a regression testing, right? It's not a unit testing. In a way, it's a user testing. Why? It's tested by the user. But we can't take it as acceptance testing. So alpha testing and beta testing are some informal testing, right? Voluntarily we do. So I will not go for acceptance testing. And of course, it is not a system testing, right? I don't know whether they can take it as system testing because we are just using it most of the time. Okay, I don't know whether, so it's a debatable. I will only go for C. Now let's see the answers. 19. Yes, answer is C. Answer is C because it's not a formal system testing. Okay, so answer is C. Right. So because anyway, don't think it as acceptance testing. Alpha and beta testing as an informal testing. Right. They are not formal system testing or acceptance testing. Okay, so answer is C. 20. Which of the following is are not a software quality attribute? Right. Quality attribute. A. Complexity. Complexity is not a quality attribute, right? Quality attribute means performance, maintainability, right? So complexity is a bad thing actually, not a quality attribute. Affordability, right? So affordability is a quality attribute, right? If it is a affordable software, that is a good thing. So here quality means good things, huh? So yes, affordability is a good thing. Modularity is a yes, modularity is a good thing. Efficiency is a good thing, right? Intangibility, no, that is nothing to do with that, right? So again, affordability I like as a quality attribute, modularity, efficiency, right? But the thing is, affordability is indirect thing, modularity is also indirect thing. Something that user really see is the efficiency. If end user's perspective it is efficiency, but developer's perspective, modularity is also there, right? Customer will look like affordability also, but I don't know whether they will take it as a real quality attribute. But anyway, I will take the answer as not quality attributes as A and E. A and E because anyway, let's see the answer. 20. Right, so for them answer is A, C and E. So that means they have not taken C, right? So they have, so these two answers are correct because they are asking not, they have not taken C. So now let's see why examiner is thinking like that. So he thinks that modularity is not a quality attribute. So one reason might be modularity is something seen by the developer, right? Developer, not by the end user. Again, it's again something that I disagree with the examiner, so that kind of things can happen. For me, quality software must be modular software, right? Quality software must be modular software, right? So when we are developing something, we have to think about maintainability, modularity, portability. So if you have those things, it's also for me quality software, right? So anyway, so what the examiner has thought in this case is on from the customer's perspectives only. If you look at the customer's perspective only, yes, affordability and efficiency, because he don't see the modularity. But again, this is something I little bit disagree with the examiner. For me, B, C, D, but your paper it is B and D. Okay, right. So let's move on. So that kind of things can happen. 21. Right. So we'll do only the MCQs. Okay, we are running out of time. Second paper, you have the answers with you. You can always double check with the answers. The problem that threatens the success of a project but which has not yet happened is called what? That possible bad things are called risk. We just discussed in our last slides. Okay, it's called a risk. It's called a risk. My answer is D. Yes, answer is D. Answer is D. Answer is also answer is D. 22. Which of the following statement is are true? Usually, maintenance costs are greater than development costs. I just mentioned that, right? Development will take only about maybe 6 months or 8 months or whatever, but the maintenance will be there for another 10 years, 15 years, and you are going to do a lot of changes, right? So that is something we have to understand. Yes, so that is why we take that phase as a very serious phase. That is sometimes for software development teams, companies, this is the phase they get a lot of revenues also, right? Because customer is we are going to keep changing, right? Because the customer need it, not because we like it, right? Second one, team stability and the effective use of case tools reduce the maintenance cost. Yes, if you have the effective use of case tools, it's going to reduce the maintenance cost. If you have the team stable team, it is going to reduce the maintenance cost. I will go for that. Okay, I will go for that. So those are going to be good things, but challenging things, right? Especially team stability is a challenging thing because the team members want to move out of the project to new projects. C. Adding people to the late software project make it faster. So that is not going to work. So that is project management concept. No point adding people late. If you want, you add those people at the upfront, because otherwise these people are going to struggle understanding the project and the design. Rather than they help us, we have to spend time with them, right? Helping them to understand the project. Now we are wasting our time also because new people are added late. So that is not going to help, right? So that is going to help if you are doing something like manufacturing, right? If you are building something, you can add a few more people to speed up the painting, a few more people to speed up building of a wall. But that is not the case when it comes to software development, because it's a complex task. New people are going to take a lot of time to adapt to the situation, understand the current situation. Okay. So that is the difference between the normal development, building things, and software development. Okay, so I will not go for C. D. Risk which affects the project schedule or resources is called product risk, right? So the project schedule. So that actually I didn't explain to you because it is in your risk management subject in your say next semester. So we can categorize risk into process risk and product risk. Process, anyway, both are PR, process and product, and some part we can just take it as business risk. So we will be discussing all those things in your project management, because risk management is part of project management. So now you can see that this project schedule or resource related things are not something to do with the product. Product risk means something to do with your requirements and stability and stuff like that, right? So therefore, and also design. So this is nothing to do with the product. It is a process risk, right? So anyway, if you are aware of that only, you can answer this, right? So therefore, this is not product risk. It's a process risk. Expert knowledge is used to estimate the software cost by analogy. So costing by analogy means, anyway, I didn't go into details because it's very quick revision. Cost by analogy means you look at similar projects that you have done in the past and do the costing. So that is called cost by analogy. Cost by analogy. There's another approach called use of expert knowledge, right? But usually what we do is we combine this and this together, right? We ask expert to look at our past project and do the costing, but if we are doing that just the cost by analogy, we don't need the expert as well, because we have those values with us. Therefore, these are, we will take them as two different things. In that case, I can't say these are related, okay? But sometimes you can relate it, but those are two different costing mechanisms, right? So therefore, answer for me is A and B, right? Right. So the answer for in the research sheet is also A and B. A and B. 23. What is or not part of the risk management process among the following? So we discuss the risk management process. Okay. Risk identification, of course, right? Unless you identify a risk, you are not going to uh, do anything. Right? That is yes. Risk manipulation. There is nothing called manipulation. You can see that the examiner is really like this word manipulation, right? So because manipulation means exploit, right? So that is not an answer. So whenever he want to make a wrong answer, he introduce this word manipulation, because it's something like identification, right? So fication. So examiner like to use that word. So this, I think, second time you find this manipulation. So that is not part of it. Risk monitoring, right? So risk monitoring means what? So that is not actually risk monitoring. It must be risk control and monitor. So yes, yes. So we take that as answer, because we have to monitor and control. We have to keep on monitoring whether risk is getting increased, risk is getting reduced, right? Then only we can do the control action. So I will take it as answer. Answer means the correct one. Risk verification. So whether we have to check the verify the risk. So that also sometimes yes, just because someone says it's a risk, we can't take it as a risk, right? We have to verify whether it's a risk. But that is not a major task also. So that is debatable answer for me. Risk planning, yes, we have to plan for risk. We have to plan for risk. Okay. So for me, so what they're asking is the not once, right? Not once. B is the answer. I don't see risk verification as a major task, therefore I will take this also as a not answer, right? So in that case, the not ones are B and D, B and D. Okay, so I'm double checking the answer now. Answer is B and D, yes. So remember, risk verification is not a major task. There is no major task like that. Therefore, it is, they have taken it as wrong answer. Answer is B and D. Okay, right. 24. 24. What among the following is are the cost estimation techniques of a project, software project? Now you can see the examiner is really interested about the cost estimations, etc. Ethnography, no, ethnography is something to do with the requirement analysis, right? Function point analysis, yes, we just briefly mentioned in your slides also. Function point analysis, lines of codes. Capability maturity model is something to do with what? We discuss it under quality assurance, right? CMM. CMM is nothing to do with the costing. It is quality. It is quality, right? So C is not the answer. Actually, there's another model called a COCOMO model, right? So I think what the examiner is trying to do is there is a model called COCOMO model, right? Which is, I think, mentioned in your note, right? So if someone has mixed it with CMM, you are going to get caught in this answer, right? So remember, CMM is something to do with the, we discussed this today. CMM is something to do with the quality assurance standard, right? Then expert judgment. Of course, we can use expert judgment, right? Expert judgments to do the estimations. Observation is an analysis technique. Okay, so for me, answer is B and D, right? So yes, answer is says B and D, B and D. Okay. Right, so now we are moving to the 25th. Okay, that is the final question. whom among the following is are responsible for sprint meeting? Now you can see they are talking about the sprint, right? Sprint agile. So for example, when it comes to agile, everyone must attend the meetings, right? Everyone means only there are three type of people there: scrum master, product owner, and team members. Only three type of people are there. Scrum master, something like a project manager, but he is doing more facilitator and coach role. Product owner is the one who is going to own the requirements, preferably from your customer side. And all the people who are doing coding, designing, testing, rest of the people are called team members. Now it asks who is going to responsible for the sprint meeting, right? For me, actually, for the sprint meeting, everyone must be there. Everyone must be there, right? So unfortunately, the answer says B, Scrum Master. Scrum Master. I think the way I interpret the question and the way the examiner interpret the question is different. I think what the examiner think is who is going to set up this one, right? So who is going to take the major responsibility of driving this meeting? Of course, the person who is going to drive this meeting is a Scrum Master, right? So that is how the examiner has think, I think, because it's Scrum Master who is going to do all the driving, but it is the responsibility of everyone. So that is another concept in Agile. Everything is a responsibility of everyone. So that is why for everything, everyone is invited. Everyone is invited for every meeting. Everyone is invited because we think take the collective responsibility of the stuff, right? But anyway, little bit debatable answer at the end also. So the examiner says Scrum Master. For me, everyone is responsible for this. Of course, I have to agree with the examiner. If he thinks like who is going to have the major responsibility, yes, then Scrum Master. Okay. So right. So that's it. Then you have the second paper that I am not going to do right now, right? So those questions are not that difficult. Second paper questions, right? So you can just go through that because you have the answers also, right? So most of the questions are just theory. Okay, right? So then we are going to. I hope this revision helped you really, right? So that is my expectation. If you feel like it is too lengthy or it is too short or whatever, anyway I will be uploading this to the YouTube as well, the second part as well. So you can just comment on that, right? So it's really helped me to do those kind of presentations in the future also. Okay, right? So thank you.